afternoon, everyone. I'm Leah Guccione. I'm a consultant with the Rocky Mountain Institute in Colorado, and it's my absolute pleasure to moderate this conversation with the companies that brought you the Interconnect Microgrid. So, Danny?
Hi, my name is Danny Kennedy. I'm one of the co-founders at Sungevity and also work with an incubator called SunCube, which is trying to support solar entrepreneurs.
My name is VERGE Kaufmann. I'm with All Power Labs, and we generate, we've got a biomass generator.
I'm Bill Becker. I'm the Director of Business Development at Spire. So we're the control system supplier for integrating the microgrid in coordinating the resources.
I'm Ed McCullough, Director of Engineering with the Station A Group at NRG, and we're going to be taking on this microgrid after the conference, so we're excited about that.
Charlie Brown, the Assistant Chief Engineer here at the Palace Hotel. Just help facilitate getting stuff in.
Jonathan Hart from Schneider Electric, responsible for corporate solution marketing worldwide and doing a lot of microgrid implementations in many different places and parts of the world.
Fantastic. And as I mentioned, I'm Leah Guccione. I'm a consultant with the Rocky Mountain Institute, and I had the privilege to join these folks in the coordination and promotion of the Interconnect Microgrid. I also want to point out that there's a number of folks in the audience who are also part of constructing the microgrid. So what I hope is that after we kind of tell some of the initial story of how the microgrid came together, that folks in the audience can contribute to the conversation with questions and comments as they come up. So please just raise your hand if you'd like someone to elaborate on something or you have a comment that you want to add to the conversation. There's just some technical details about the microgrid that are sort of scrolling behind us for you guys to just take in some of those nuances. But I want to ask Bill now and the other panelists to talk about how did this microgrid, this interconnect idea really come together for your organization?
So I'll be honest, my smart guys are in the audience. So basically what we did is we were getting involved with how are we going to pull together a microgrid. And microgrids always have this element of, okay, well what's involved in the microgrid? There's many different kinds of assets, generation assets, controllable load assets, storage assets. So we started looking at the pieces we had, and we looked like we were going to have solar, looked like we were going to have batteries, looked like we were going to have gasifier, biomass. And so we started looking at all these pieces and figuring out what pieces did we need to actually pull together this microgrid. And of course, you know, as some of you may have heard, some of the pieces didn't all come together in the end. So as we were working through the challenges of what was going to be in this microgrid and what we were going to be able to do with it and how we were going to coordinate the assets, that was somewhat of a moving target because we weren't sure what was going to be there, how we were going to connect to it. There was a lot of things that actually happened just last week as our team did the hot staging out at the All Power Labs facility, trying to get everything ready before they could ship it over to the alleyway next to the hotel. So there were a lot of kind of on-the-go challenges, but in some ways that was unique to a demo. In other ways, you know, all microgrids have all sorts of those sorts of challenges that you know, we're fairly new at doing this, especially with high penetration renewables. So we're all, you know, it's a moving target sometimes.
Danny, you know, Sungevity is bringing the solar assets to the microgrid. When GreenBiz and the rest of the team came to your organization and said, hey, we're building this interoperable, portable, fully functional microgrid, what was the opportunity that you really saw for Sungevity, and what did you really want to try and demonstrate by participating in this microgrid?
Well, the opportunity we were hoping to go for was to do with the roof, obviously, which is where we want to go. So it wasn't so much to be quite part of a portable, but with only sort of 6 weeks or so to get it organised, it turned out not to be possible either with the 70+ kilowatts we think that this hotel could sustain, or even the 5 kilowatt sort of portable, demountable system on the roof that we had hoped to do. So we ended up deploying our 1 kilowatt ice pop truck, which is more of a marketing tool, I'll be honest, and that's great because it demonstrates this incredible modular generating resource that photovoltaics represents. But it also shows the challenges Bill just mentioned, that, you know, often it's not the physical or, you know, the ability to actually logistically deploy PV, it's going to be regulatory barriers, practical barriers, like, you know, the seismic testing required for this hotel to have a rooftop system to get permits and all that stuff, which is good learning. I mean, microgrid scaling globally will be oftentimes delayed because of regulatory, political, and social impediments as much as anything.
Could you elaborate a little bit on what you're trying to do? I should say perhaps the ongoing and future relationship you're hoping to have with the hotel for the larger installation?
We're a business that's grown up on residential sales, and we're just now starting to explore the commercial space. And we think a partner like Starwood would be a great one. That's the chain that manages this lovely palace. And we could think of no sort of better way to get into that than doing a demonstration like this that's going to be used for multiple years, hopefully for the VERGE Conference, to continue to have this conversation that we've been having this last couple of days. And also the history of the palace is just such a beautiful story to sort of go full circle from 1908 when Westinghouse stuck a huge turbine downstairs in the basement that will never be removed because it's so big and heavy. It's going to be there until the next big one. And you know, just that idea that this was the power plant for Market Street's lighting solution and the newspaper industries that were printed around here and the hotel guests getting the special service of electric light, to go full circle 100 years later and build a real permanent thing would be a wonderful opportunity. We hope to be part of that in the next year without being overly ambitious.
Well, and we are here next year for sure, last week of October, so we have a year to work on Charlie Brown and the team to convince them.
So, Charlie, could you just characterize the reaction that you and the other members of your facilities staff had when Greenbiz came and said, we would like to build a functional portable microgrid in your exhibit hall?
Surprise and disbelief at first, but we've seen many events come in here that have surprised us before. This being energy sustainability and oriented, it's pretty good. It seemed like a pretty good idea. Yeah, 6 weeks is probably not quite enough time for permitting here in San Francisco. But I would imagine that with the length of time now between the next show, that we should be able to do that. I welcome it, of course. I've got a PV system at home too, and still above the line with it. See what happens in the winter.
Great. Could you, Danny touched on it briefly, could you tell our guests a little bit about the history of the hotel's energy system and sort of what that does for you guys in terms of your motivation and your inspiration in managing the hotel today?
Personally, I've got the desire and every effort, I try to be a green effort. Sustainability is a Starwood directive as well. And I'll do what I'm told here at work. We all treat that generator with the same kind of history as the ballroom downstairs. The garden court is the beautiful historical monument. Well, that's kind of our monument down there too. I don't know that it'll ever run again, but it would be nice to have somebody tour it and all. So the way you put it is, come full circle over 100 years later and have sustainable energy. Put that way, it sounds great.
Fantastic. So there, All Power Labs has an incredible technology, and you're an incredible organization to be, I think we're really privileged that you guys were able to come and be part of this demonstration. Could you tell us a little bit about All Power Labs and then talk about the opportunity you guys saw to participate in the Interconnect Microgrid?
So All Power Labs started about 5 years ago, and we heard about gasification as a technology, and we're interested, enthusiasts earlier, and we really wanted to open up and kind of introduce that technology to others. And so we started with creating small kits that allowed people to explore this technology and hosting workshops. And we've hosted a lot of those kinds of things and really shared a lot of information. We wanted to get that kind of discussion going, And we've incrementally, released early and often products and wanted to get things out into the world and really kind of step through the technological evolution, get this concept out. And so as we've stepped through it, for a few years we've had generators that have behaved like a standard backup generator as an isolated system. We've recently introduced this grid synchronization capacity with another piece of equipment, and by integrating those, we're now stepping into that domain. It's a great opportunity on the. We've demonstrated this on larger grids, working in Italy and elsewhere. It's a great opportunity to now see how can this work in these smaller grids. There's other issues. There's more variability and other things like that, and it's been step through some of those challenges. Learn from.
Are you comfortable saying why you developed it?
The grid tie function?
No,
or
no.
the equipment itself?
The equipment itself.
Why? Well, personally or as a company?
No, as a company.
As a company. We think that there's, we want to move towards renewables. We think there's a strong proposition with biomass. It won't solve everything, but it's one piece of a renewable puzzle, and as those all come together, hopefully there's that can fit into it. And we're pretty committed also to this kind of decentralized and distributed small-scale generation. We think that's where biomass fits because of all of the logistics around it.
Great. So one of the things that Bill mentioned that I'd like to go back to him about is that there were a number of different technologies that we wanted to feature in the microgrid, but not all of them were able to come together. And there's a variety of different reasons why that happened. So I'd like to let Bill and Jonathan talk about what the original plan was to try and feature a battery, and sort of some of the challenges that happened that prevented us from actually incorporating that energy storage asset in the microgrid.
I would say one of the biggest challenges was the 6 weeks or 4 weeks by the time we heavily got into it, or the 2 weeks before it actually started coming together. So, I think the battery in and of itself was a solvable problem, but we had actually somebody willing to put forward the battery for the project. What we couldn't do is coordinate an inverter, a 4-quadrant inverter that we could charge and discharge from the system that was compatible with our system. So, absolutely solvable problem. We couldn't solve it in the time frame and at the amount of money we had to spend, which was none. So those are some challenges. But inherently, it's I think it's indicative of the fact that generally these technologies are somewhat newish, being applied in this way in a distributed fashion, and you can't just go down to the local dealer and go pick what you need up. So I think that was part of the problem. And in the end, we fortunately had a very versatile asset in the gasifier, so we were able to balance with that. But that was some of the challenges that we faced.
Absolutely. Jonathan, you want to talk about sort of your technology and some of what Schneider Electric's doing to provide the flexibility and the array of technologies for customers to meet different needs?
Yeah, I guess just picking up on that, I mean, the fact that you see this many people, and we had to remove a few chairs from the panel as well, just goes to show that when you start talking microgrids, it's not an off-the-shelf solution. It's about various different elements of technology coming together to really get there, and I can pretty much guarantee you it's pretty impossible in 2 weeks. But what's been achieved here is fantastic in that time frame. Just to give you another example, we've created the microgrid for a competition called Solar Decathlon that many of you probably know and have seen, and just finished last week in LA. But the microgrid that we produced in 2011 for in Potomac Park was reused this last couple of weeks in LA. So we manufactured it, produced it, the DOV have used it and shipped it in multiple different places. But that took about 9 months to actually create. And yeah, technology exists, all the pieces exist. But what's actually more critical is about all the players in there. So when we looked at that microgrid, it's about connecting 20 homes who've got a solar capacity of about 150 kilowatts into a grid, and all of those are designed to such a high level that they're all producing more power than they consume. So then the question comes, well, what do we do with that power? What do we do with the surplus power? We had to kind of strong-arm a bit Pepco to disable the network protector on the transformer to the grid, so that they could take two-way flow of power. Luckily, with the Franklin Roosevelt Memorial, there's so much power being consumed by the water pumping systems that all that excess power was already consumed at that level before heading any further back down the network. But it took time to actually convince Pepco that they wanted to do this, that they were able to accept this, that it was something that actually made some sense. And this is also another big challenge we come to when we start talking about microgrids. It's great if you're completely off-grid. You can put in place and design complete off-grid solutions that work very effectively from solar right through all the electric distribution network. As soon as that gets into an area where there's a grid, existing grid, where there are integration into existing urban environments onto existing buildings, then it starts getting a little bit tricky. Then it means that you've got a whole load of different aspects and requirements coming into place, which are over and above what the technology can actually do. It's about getting all those people together to the same common goal and vision as to what's trying to be achieved. Once you've got that, then things actually go quite quickly, because it's then left to the people to actually get on and build that. But the amount of blockages that you find along the way, because it's something new, because it's something that is out of the norm in terms of what people expect to see, means that unfortunately we're still talking a lot of pilot projects and nice ideas and demonstrators and trying to convince, and at a certain point, I think we all hope that this will become more than just pilots and demonstrations and ideas, but become more mainstream, because it is a fundamental answer to a lot of the problems we're facing today. And how do we take that and scale that from a single building microgrid to a residential district to an eco-district out to much wider areas, which will invariably become utilities of the future, because they'll be able to interact and exchange energy between themselves without even needing to contact the utility. Pricing will be set between neighbors, between people within that microgrid. I'll go on holiday and I'll start selling these guys my power that I'm generating but I'm not going to consume. But I need that microgrid to be able to feed that through different consumers, different loads in that local group and that microgrid. So I think when we look at it from the example we've got here, if anything, it sets a really good example of how challenging the future is going to look, but how it needs these sorts of activities to get people to wake up and really ask the question. I mean, the classic question that was asked to local utility, why can't we connect it to the grid? So, well, that's probably more a question you should be answering than asking us. But it's one of those elements that has to come into the discussion, and we have to get all of those people together and sitting around that to look at the future.
Absolutely. Ed, could you tell us a little bit about what NRG is looking to do with the Interconnect microgrid, and why you see this as a an important learning and research opportunity for your organization and the industry?
Yeah, I think for us it's a great opportunity both to serve as a demonstration tool like it's serving at this conference, but more importantly as a test bed for microgrid technologies. I think, as Bill alluded to earlier, there's kind of an inherent dynamic aspect to a microgrid. So if we have more solar available or more potential solar available than the current microgrid. So integrating that, we also have a warehouse that we've repurposed for our offices, and we've implemented some open source building management systems and some CHP potential into our HVAC system. So we can recover waste heat and use that to heat and cool right now to heat the office area. So I think that going through that transition of implementing these additional aspects that we have on our site is going to be a great way to get our hands dirty with this microgrid and build up our experience at this scale. Our facility, we're located on a 22-acre site of a former power plant, which was actually the first power plant in San Francisco, which has a poetic aspect to it, but also we've got huge tanks, so we could in the future potentially do compressed air or pumped hydro storage. That's further out. But we also have large battery banks that were used as backup power for the control system in the power plant. But I think that I think it can serve both that demonstration and test bed purpose, and allow us to kind of harken back to the power producing days of that site.
Awesome. So I want to try and share with the audience a little bit of the excitement that was the effort to bring the microgrid together. So as a sort of a general question for anyone to answer, what was the most insightful or interesting challenge that your organization faced, or perhaps lesson that you learned in bringing your equipment and your capabilities together for the interconnect demonstration?
Okay. One interesting thing, going from having push power to other larger grids where you have a huge amount of capacity, something to really look at on the control side. We're seeing this when we have 2 generators right now. We're offsetting basically a diesel generator on this microgrid, and running into the dynamics. What happens when we don't have dispatchable loads? That if we're trying to push against this other generator, interesting things happen in terms of so so there were interesting dynamics there, and how do we manage that to make sure the load is appropriate to prevent that scenario. That was one interesting.
I think for us, we're exploring playing with other kids in the sandbox with other technologies and these sorts of controls and things anyway, and then the commercial scale is another learning curve for us that we were interested in this as an opportunity to do. But again, to repeat what I said earlier, the barriers became more about what are the permitting requirements in this built environment with such a magnificent old building at this scale and in this city.
There isn't necessarily, you can't just necessarily standardize away from some of that detail engineering. And I think things will change over time. Things will become more standardized. There will be more communications-based interfaces, hopefully with some standards that are actually meaningful. And so those pieces will become simpler. But where we are right now, you're dealing with a lot of existing equipment, legacy equipment, and it takes some time.
Anyone else?
I'm sure we're going to have plenty of lessons to learn.
So, Eric, can I ask you, what was the most interesting thing that you learned in the construction of the microgrid, or perhaps the most interesting challenge that you faced?
Where to start? Well, I mean, it's funny, Elaine Shea, who's our program director, is an engineer by training, and for those of you who didn't hear my opening session, my favorite trade show in the world is called Interop, and Dan Lynch, who launched it, it's the most visceral experience of a trade show because it was all about the networking space and TCP protocols, and he literally said, you can't pay me to be on my trade show floor unless you can plug into my network. And I've always thought that is the coolest trade show. I mean, Interop still exists today. They don't force people to do that. So with Verge, I just kept trying to think of how can we make this thing real, and somehow on a run one morning, it just hit me. It just was like, oh my God, we should build a microgrid. And I came into work and I told Elaine, we should try and build a microgrid. And the first thing she said was, there's no way you're going to build a microgrid. And of course, that just instantly got me, I have to build this microgrid. Well, that was responsibility. So it was really more about a roller coaster. It was more, then I connected with the Spray guys. They came to the conference last year. A guy from their team came and found out, Elaine started telling people, she would say, we're thinking about building a microgrid. And so they jumped on board, and the pieces would start to come together, then all the pieces would fall apart. You know, we would see that we had the idea of it, and then something wouldn't work. And, you know, my credit card has lots of charges for equipment that fortunately is going to find a home, because it's extremely esoteric, weird stuff that we have to pull together. But it ended up being exactly what I would hoped it would be, which is the version 1.0 of this. And the failures, I don't want to call them failures, because there really is no failure. We have a working microgrid out there. That is the bottom line. And then it's really more about the opportunities to do what we were hoping to do this time next year. And the idea that it has a sort of a permanent hot staging, if you will, that we can go and test stuff and try things and then come back next year is great. It's really, and I thank you to everybody involved. I mean, I'll say the city, the first people I called was the city. I called Melanie Nutter to say, will you guys let us do this? And she said, we will make sure that you get the permitting to do this. There's nothing here that shouldn't be permitted. She did say you'll not be able to plug into the grid, and you need to call PG&E and tell them you're doing this. And PG&E has been a supporter of VERGE from the very first year. And they said, we think this is really cool, you're not going to plug into the grid. I mean, I think Melanie would I think she'd like to see, I think the city in general would like to figure out a way, could we eventually plug into the grid here? But, then the hotel, Jerry and team, the first time we met them, they said, this is really cool, we'll support you. And when the fire marshal came yesterday, Jerry and his team were out there ready to do whatever they had to do and lent us the fire extinguishers and the little detail stuff that the fire marshal wanted to see. But, I'm super excited. So thanks to all of you guys.
Absolutely. So one of the things that I want to, talk about now is taking the macro view of microgrids. And Bill, you sort of touched on this earlier. There are a lot of things. This microgrid is unique in terms of what it has done, but it's also unique in terms of what it hasn't had to do. You mentioned that the budget was zero, and that the participants, they saw an opportunity to demonstrate the capabilities of their technology and to do something collaborative and innovative, but nobody once had to prove the internal rate of return or the payback period for this microgrid. And because we're not interconnected with PG&E, nobody had to try and file for franchise rights with the city of San Francisco. So there are these real barriers that actual microgrid owners and operators have to face that we didn't have to face. And so what I'd like you guys is, from the viewpoint of your organization, because we have such a great diversity up here, what do you think is the most either significant or important barrier that is out there for your technology to help proliferate microgrids and distributed generation? Danny, can I start with you?
I think it will be money. I mean, the politics will follow. Right now in this country, there's remarkable resistance to DG, or distributed decentralized models of electricity generation and distribution. But I think that will pass because the economics will stack up on our side of history. But then getting finance to flow behind it, we've got to get the cost structure down.
Right. So, Bear?
Yeah, I think it's been touched on before, but a lot of these just kind of political things and the kind of comfort of the technology, or that there are working examples in this, and that this can be something I think accepted and more accepted as a general thing, so that it does become easier to encourage.
So I would, the technology stuff that we can solve, and I think you made a good point. I mean, we've done this. The pieces exist. We can do this. I think the biggest thing, it comes down to money, and I would argue that the reason that the money isn't there is because we don't have enough value streams that we can extract, and part of that's built on the regulated model with which power is traded and consumed, and single source of supply from a utility. It's hard to construct creative business models that extract all the value. You talked about the complexity of connecting to the grid. that's true. There is some different complexity, but there's also a whole lot more value we can potentially bring in terms of playing in markets, providing support services to the utility, doing all kinds of interesting things, utilizing this distributed generator, which is, you know, how it all started, right? Is distributed. Then it got centralized. Now we're realizing, well, we can take distributed and extract more value. But you can't necessarily extract the money for the value just because of the way the regulations are set up. So in order to get the money flowing, you need to be able to create the interesting business models, and that will then get the projects to go, because I'm convinced there's value there. There's no question that the value is there, but to be able to extract it from multiple sources and put a business case together and find somebody to finance it, that's a tougher nut to crack.
Ed?
Yeah, I think there are places currently where it makes economic sense to install microgrid. Like in the Caribbean, for instance, there's a lot of wind and solar asset available, and there's people are paying a lot for diesel, electricity produced by diesel gensets, so which isn't very reliable either. So I think certain places like that already make economic sense. It's just a question of somebody coming in and actually installing the generating assets and taking on the ownership and ongoing maintenance of the equipment. Then beyond that, I think in order to get more penetration into the rest of the market, I think that we'll never have like an off-the-shelf microgrid. Everything, it's always going to be somewhat customized. But I think trying to get to more of a plug-and-play or productized or templatized model is going to be key. And I think that there's like Spray is working on making their software architecture more modular, so you're taking pieces that already exist and combining them, so that the non-recurring effort for each of those is reduced.
Great. So,
the hotel's always going to be interested in the cheapest power available. We go through every effort to reduce what we consume now, and we'll make an effort to purchase the cheapest available too. The room here is illuminated with LED lighting, except for these sconce lights around the corner. Most of the rooms here on the second floor where that doesn't pay for itself for a long time, but reducing our energy bill shows that right away.
absolutely. Jonathan?
I think what's interesting is the kind of a geographic split as well. Living in Europe is actually quite nice because there's a general willingness.
Just in general.
I'm an English guy that lives in France. There's some ups and downs on both of us.
Wait till the Gulf Stream shuts down.
But the general spirit is one where the need to integrate renewables into the energy mix is a given. It's actually now legislated. That's something that has to happen. We see Germany saying, we're shutting down nuclear, we're going. We see France saying, we want to keep our nuclear, but we know we should put more renewable into the mix and we should see how it happens. So, firstly, kind of the mind's a bit more open that something like this has to happen. The only way financially to make it happen is that it's too costly to build massive solar farms and wind farms, and therefore decentralized and distributed generation is a given. It has to happen. Now the question is, how do you want that to happen? And it's at multiple different levels now that we're seeing. We're seeing complete off-grid solutions. I'm never going to connect to the grid, I never want to connect to the grid, but bringing that into play now gives me a huge amount of opportunity. Because what it's doing is you put in an off-grid solution is actually bringing energy, electricity, the ability to start to generate business, get people moving and developing. We've got other examples, which is the microgrid at a single building level. So we have some of the first net positive buildings and office buildings in France. If we look at one of them was built by Bouygues with ourselves, it's now so granular that they're now monitoring and managing a 2 meter by 2 meter space, independent in terms of lighting, heating, ventilation. But the key thing is they're allowed to connect to the grid. It includes Microsoft, it includes Bouygues, it includes electric vehicles, it includes weather systems to understand when the sun's going to be shining strongly or not, and therefore how to plan all these different pieces in. But it becomes an independent group that get together to share and shift capacity and loads at that sort of level. So what's interesting is, depending on where you are in the world, people are more open or more closed to putting those things in place. The rules are very different, country to country, system to system. Feed-in tariffs exist or don't exist. People are open or closed to it. And I think we'll see certain areas of the world go very fast. I mean, we were talking about Denmark earlier. When a country sits there and goes, we're going to be 100% renewable in the next 10 to 15 years, it suddenly changes completely the dynamic of what people are allowed to legislate or not, and where people are allowed to stay in their opinions. And what we've seen very quickly in Denmark is no one gives a crap about whether the utility has to block or can't block or can or can't. The only thing that's important is that anything that gets them towards that target is good, and therefore gets legislated, which means banks are willing to finance because they understand and get it. Sure, they're going to put some constraints in place in terms of the deal and what happens, but the banks are open and they get the benefit of doing efficiency, doing renewables, doing distributed generation, because their mindset has been tuned in that particular way. So I think we'll see a lot of different things happening. We'll see things go more rapidly in Europe, incredibly fast in China, because they also have set that in their guiding plans. The 12th five-year plan says it's minus 25% energy consumption per point of GDP. The only way to do that is more renewables, more microgrids, more distributed generation, and a mindset of really optimizing every single point of consumption in the local zone. So I think we'll see a big shift in the next couple of years. And the great examples that we've started demonstrating today.
I want to give a chance for anyone in our audience to ask a question. Yes, sir?
So, okay, I get it. It's a bunch of parts. Who's going to design putting them together? And who's going to be in the business of project managing this to build it on the customer side?
I mean, there's several different roles in that. And by the way, we
That
wanted
was
to
a
have,
softball for you.
we wanted to have a fuel cell as well, but we couldn't get a fuel cell supplier.
That's because we couldn't get a gas feed to the sidewalk.
It was another possibility, but so there's a bunch of different roles that you described there. There's a developer role. There is the project, the detailed project management of getting through the project. There's the financier piece, and you got really big companies and you got really small companies, and you have probably smaller yet companies. And so there's a lot of different roles here. And I think the short answer is we don't know how that's all going to shake out. I think what you're going to see is small companies like Spray doing a lot of innovative things. You're going to see big companies like Schneider coming in and with certain groups doing a lot of innovative things and then taking it on in a much bigger corporate type role. And you'll see that with other companies like the GEs and the Siemens of the world. I think there's going to be a bunch of different roles as we sort out all the details of the different pieces, and I think we all bring different skill sets to that. So it's one that I think will evolve significantly over the next few years. And I do think the U.S. is starting to see a lot of activity, because there's a lot of places in the U.S. where solar and solar in particular is starting to impact the grid. So I think these are the places where you'll see the initial activity: Southern California, Arizona, Caribbean, Hawaii. So it's not all Europe. It's certainly things are changing here, whereas 3 years ago I wouldn't have said that nearly as much.
To developing countries, you're already starting to see standardization of these things rolling out through companies like Standard Microgrid, Power Hive, Auto Dynamics that do a microgrid out of a container kind of trick. But to me, the place that this is being done best as cookie cutter or sort of sausage flipper is the military. And Leah, to put the question to you, she didn't introduce herself very fairly, but used to run a microgrid on a small floating community called a nuclear aircraft carrier. Which, these guys know how to do it out of the box, right? And they've done it in forward net stations the last decade in Iraq and Afghanistan, unbelievably, with solar as a core asset, fuel cells even, all these tools that we're talking about in the military are going to actually make this scale.
Absolutely, and to that point, in our existing energy ecosystem, there is a great diversity of different business models where you have, and some of that is driven by policy and what is permitted by the local regulations. But you have the companies that just want to design build, you have companies that will design build, operate, maintain, you know, you have guys who just want to maintain. And right now, our energy infrastructure is such that depending on what makes sense in the geography, in the financial environment, you can successfully execute on different business models. And you know, you go to the universities, and they're totally, most of them are totally vertically integrated. Like, they act as their own ESCOs, they want to operate the facility themselves, they maintain it themselves. You go to places like the military, and forward operating bases, that's absolutely the case. They do it all themselves. But here at the in-country facilities, a lot of maintenance and operations is contracted to private companies. And it depends on what makes sense, and that's going to be circumstantial. And so I think there, even with this technology, there's going to be room for diversity in business models and service models. Go ahead.
So my question is going to betray my ignorance, but you've talked about the microgrid. I've been surprised I haven't heard that much about metering, smart metering, data networks, and then smart grid. So is that all just inherently in this, or does it kind of depend on the scale? And then as we're scaling, does it have to, it becomes smarter? What's the relationship?
I think it's a good question, because what you've got here is a small example of what can be done. But as you start to scale up, you're going to need to start prioritizing loads within that system. Because at a certain point, there will be demands on an energy system that says we don't have enough capacity to make sure that we can deliver. Therefore, the sub-metering, the power measuring, the power monitoring, the control of all of those diverse loads becomes a critical, integral part. Because it's about how to monitor and manage that. At a certain point, depending upon the country, the network, the grid, there needs to be a connection into that grid. Because where the smart grids and the microgrids have a great role to play is in terms of demand response, in being able to provide supplemental capacity or shaving off capacity as required, depending upon the demand needs in those different countries. So as we move forward, it's becoming more and more critical to have intelligence across all of those different points, to be able to optimize what's going on and know exactly when and how to prioritize within that network.
Can I add to that? All of those elements are in our microgrid. So there's communications, there's metering. One of the things a few years ago when the term smart grid started getting used a lot, we thought, oh, it's great, it's something to describe what we're doing. Well, then all of a sudden it started meaning everything. It was in-home displays. It was AMI, basically the automated meter reading at homes, and it started meaning nothing very quickly because it was just being applied to everything. So it's in the end, it's all about connecting. Instead of having one central power source and a bunch of distribution to a bunch of fixed loads, now all of a sudden we have loads, flexible loads, generators, all interconnected, thousands to thousands, millions to millions, instead of just one to millions. And so all that infrastructure supports all these things we're doing. And microgrid is one of the things that we're benefiting from all this infrastructure. There's a lot of other things that we can do that are variations of microgrids, but utilizing that same technology to enable all this connection of many to many of flexible demand generation at a local level, being able to sell to your neighbor, maybe through some sort of aggregation. There's some smart city projects that are going on that are exploring these things. And part of the goal is to develop business models that will actually make this all work, because today the regulatory climate makes it difficult.
Exactly. And one of the things that I always consider when people ask about smart grid versus microgrid is that smart grid capabilities make a microgrid better. And having a microgrid gives you new capabilities with your smart grid infrastructure. So they are different, but they very much complement each other and create a lot of new possibilities.